We're in section 2.4. Electronics, let's put them away, please. Put the electronics away, not just under your leg, not just under your notes, but away. We're talking about deductive reasoning. So, just quickly, let's stop talking, folks. Quickly, let's remember inductive reasoning. Inductive reasoning means we are making conjectures. And what is a conjecture again? Do you remember what a conjecture is? We made a conjecture on the quiz yesterday. Yes? Yes. So a conjecture is something we think is true based on observation. So conjectures, inductive reasoning is making conjectures based on observation. And I'm going to say observation or experiment. And experiments are just a particular type of observation. We're looking at something and saying, here's what I think. I'm going to look outside and say, it's a little bit sunny, so I think it could be warm outside. That's a conjecture based on my observation. We don't know whether or not it's true until we figure some more stuff out. That is different from deductive reasoning. Deductive reasoning means that we start with what we know is true, and then we figure out what else has to be true. So that's kind of like what we did with the activity we did in class, where you say if something is true, then something else is true, and then you make a chain of those, and at the end you say, well, if the first thing is true, then the last thing has to be true. Now, some of the things that we linked together aren't necessarily true, and that's why they came out so interesting. But that's one way of reasoning. We start with what we know is true, and then we use logic to figure out what else has to be true. That's called deductive reasoning. Now we're going to talk about two ways that we're going to use deductive reasoning. So everybody good with the difference between the two? Okay? The first way that we're going to use deductive reasoning is called the law of detachment. And the law of detachment says that if we have a true conditional, so something like we had on the board, if today is Friday, then tomorrow is Saturday. We have a true conditional. We know the hypothesis is true. So the conclusion has to be true. So on our opener we said if today is Friday, then tomorrow is Saturday. Today is Friday, therefore Tomorrow has to be Saturday. That's how the law of detachment works. And if in symbols we would say P implies Q is true. We know P is true. So Q must be true. So that's a law of detachment. Let's look at a couple of examples. Let's start with the one we used in class the other day a lot. If you are a math teacher, so if you teach math, then you know algebra. Mr. Beamer is a math teacher. Therefore, what? Mr. Beamer knows algebra. So that's how we would use the law of detachment in math. Mr. Beamer teaches math, therefore Mr. Beamer knows algebra. If we know the first part is true, if we start with a true conditional, if we know the first part is true, the second part has to be true. Then you can't make any conclusion. You don't know one way or the other.
But you still have an hypothesis.
Still have a hypothesis, but your conditional statement is false. So you don't know whether one implies the other or not. All right. Let's look at another example. If you score more than 85% on the final, you get an A. So let's say you score 90%. What can you conclude? You get an A. So if you know the first part is true, then the second part has to be true. Let me look at another example. Let's say if you get an A, you get candy. And I'm going to say you get candy. Can you conclude that you got an A?
Well, an 86% is an A.
But so this is separate from this one.
Got it.
And this is if you get an 85% on the final, you get an A in the class, not on the final. You get an A in the class. So you do all the calculations at the end of the semester. You say I have to get more than an 85 to get an A in the class. Now I'm going to say you get an A. If you get an A, then you get candy. You get candy. Can you make the conclusion that you got an A?
Yes.
Is getting an A the only way you could get candy?
Whoa.
No, the statement just says if you get an A, then you
can have
get
an A in
candy.
the class or on the test.
What's that? But this is separate from the first one.
This is all the information that we have today.
Right,
Yeah.
this is all the information we have. So,
There's ways around the fact that
you could have bought
Yeah,
some,
you could buy some.
right? You could buy
steal
some. Your friend could have given you some. So, the only way we can use the law of detachment is if the first part is true, the second part has to be true. If the second part has to be true, the first part isn't the only way that the second part could be true.
So it can't be a counter.
You could, no, for this one, you just can't make a conclusion. You can't say that you get an A. You don't know if you got an A. So we can't say you got an A. So it's kind of like the example we used with the math teacher one. I can't say if you know algebra, then you are a math teacher.
What if it said you get candy?
If and only if.
Yes.
If it said can you get candy if and only if you get an A, then if you got candy, you would know you got an A, because it's saying if, and that means it works both ways. Yes. So that's one place you have to be very careful with the law of detachment. It's very easy. The common mistake is people say, oh, the second part is true. That means the first part has to be true. It's not necessarily that way. So all we can tell is if the first part is true, the second part has to be true. All right. Any other questions? They're good questions. Good discussion. All right. The next way that we're going to use deductive reasoning is called the law of syllogism. And that's what we did on our project in class the other day. Law of syllogism says we can link together two or more true conditionals. And notice here we said true conditionals. So part of the reason that some of our projects yesterday got so fantastical is some of the conditional statements that we used were not necessarily true, but it made it more interesting. So the way this works is in symbols we would say P implies Q is true, and Q implies R is true. Thank you. So what we can conclude is P implies R. So we link the end of one conditional statement to the first part of another conditional statement. We link them front to back, just like you did in your project yesterday. And then at the end we can say P implies R. The very first thing implies the very last thing, as long as we link them together. So that's what the project was all about yesterday. So an example of that would be, if you teach math, then you know algebra. If you know algebra, you can factor. So what is the conclusion that we make from this? If you teach math, you can factor. The first part leads to the last part. So we're just linking these together. And we can link more than one. Yesterday you linked three at least. Some of you did even more than three. So we can just link these back to back. All right. Let's look at a couple more of these with the law of syllogism. What I want to know is, what can we conclude? If a number is divisible by 12, then it is divisible by 6. Thank you, Chris. And then I'm going to say if a number is divisible by 6, then it is divisible by 3. So what can we conclude here? If a number is divisible by 12, then it is divisible by 3. So we link the two, front to back, and we can decide that if a number is divisible by 12, it's divisible by 3. All right, questions on that one? That's like the one that was on the quiz yesterday, right? Sort of. We didn't have to link it together, but there was something kind of like that on the quiz. All right, last one. If a shape is a square, then it is a quadrilateral. If a shape is a rectangle, then it's a quadrilateral. What can we conclude here? Is that what these two say? If a shape is a square, then it's a rectangle? The first one says if a shape is a square, it's a quadrilateral. The second one says if a shape is a rectangle, then it's a quadrilateral. What's the problem here? They both have the same ending. We can't link them together. We have to be able to link the end of one to the beginning of the other. So can we make a conclusion here? We could say if a shape is a square or a rectangle, it's a quadrilateral. But we're not, that's just kind of putting the two together. It doesn't link one, the beginning of one to the end of the other. So that wouldn't be wrong. But we can't link them together. So we're not using the law of syllogism there because we can't link them together. So we can't make any conclusion. All right, one last quick thing. We don't need to write anything else down. But the way we can put the law of detachment and the law of syllogism together is if I look at this example, we decided if a number is divisible by 12, then it is divisible by 3. I'm going to say 24 is divisible by 12. What can we conclude? 24 is divisible by 3. So that's putting those two together. We've made this chain, and then we give an example of a number that's divisible by 12. If I go back to this other one, if you teach math, then you can factor. Mr. Grace teaches math. So what can we conclude? Mr. Grace can factor. So that's how we put the law of detachment and the law of syllogism together to make a conclusion. So our big picture here is law of detachment. lets us draw a conclusion from a conditional. The law of syllogism lets us link conditionals together. So that's the main difference between the two, and that's how we're going to use those two. All right, questions? Okay. Homework?
Yeah. 20 through 28.
Oh, and I need to pass out our new Common Core and Algebra practice. I am going to